Have you ever looked up at the night sky during a celebration, maybe on New Year's Eve or the 4th of July, and been completely mesmerized by the explosion of colors above you? It's a magical moment, one that fills the air with excitement and wonder as people of all ages stop to gaze upward, their faces lit by bursts of red, green, blue, and gold. But have you ever paused to ask yourself how fireworks manage to create such a vivid palette of colors? Why do some fireworks shimmer in deep blues, while others glow in brilliant reds or sparkling golds? The answer is more fascinating than you might think. It's not magic, it's chemistry in action. Behind every spectacular firework display is a carefully crafted recipe designed by scientists and artists who understand the secrets of the elements. The secret lies in the special ingredients packed inside each firework shell. These ingredients are chosen with precision because each one plays a unique role in the final show. Think of it like baking a cake. If you want a certain flavor, you add a specific ingredient. In fireworks, if you want a certain color, you add a specific chemical compound. The right mix can turn an ordinary firework into a breathtaking spectacle. Each color comes from a different element. These are the basic building blocks of everything in the universe, from the air we breathe to the stars in the sky. Elements like strontium, copper, sodium, and barium are especially important in fireworks. When a firework explodes, the intense heat causes these elements to get excited, meaning their atoms absorb energy and jump to a higher state. As they cool down and return to their normal state, they release that energy as light. The color of the light depends on the element. Each one glows with its own signature hue. That's why, when you look up, you see a dazzling rainbow painted across the night sky. Every burst is a combination of science, creativity, and a little bit of showmanship. This is the science of pyrotechnics, using chemical reactions to create not just heat, light, and sound, but also unforgettable moments. Pyrotechnicians spend years perfecting their craft, experimenting with new formulas to create even more vibrant and surprising effects. So next time you watch fireworks, remember, you're not just seeing a show, you're witnessing chemistry lighting up the night, connecting people everywhere through a shared sense of awe and joy. Now let's take a closer look at these amazing color-making elements and discover how each one brings its own special magic to the sky. The secret behind those dazzling firework displays lies in the world of chemical elements, specifically a fascinating group known as metal salts. These vibrant compounds are the hidden artists behind every burst of color you see lighting up the night sky. In chemistry, the word salt means much more than just the white crystals you sprinkle on your food. A salt is any compound formed when an acid reacts with a base, and there are thousands of different salts, each with its own unique properties and uses. When these metal salts are heated inside a firework, something magical happens. The atoms in the salts absorb energy from the heat and then release that energy as light. The color of the light depends on the type of metal in the salt. Each one glows with its own signature hue. This process is called atomic emission. When the atoms get excited by heat, their electrons jump to higher energy levels. As they fall back down, they emit photons, tiny packets of light, at specific wavelengths, which our eyes see as different colors. That's why, in a laboratory flame test, different elements produce different colored flames. Sodium burns bright yellow, copper glows blue-green, and strontium blazes red. Each element's color is like its own fingerprint. Scientists use this principle, called spectroscopy, to identify elements not just on Earth, but even in distant stars and galaxies. By analyzing the light from a star, they can tell exactly which elements are present, all thanks to these unique color signatures. Firework chemists, known as pyrotechnicians, carefully select and blend specific metal salts to create the exact shades they want for a show. It's a precise science. Too much or too little of a compound can change the color or even make it disappear. These chemicals are shaped into tiny pellets called stars. Each star is packed with the right mix of metal salts, fuel, and binders, and then arranged inside the firework shell in patterns that will determine the final display. When the firework explodes high above, the stars ignite and burn, tracing brilliant trails and shapes across the sky. The arrangement of the stars inside the shell decides whether you see a ring, a heart, or a dazzling burst. The color of each spark, each glowing trail, comes directly from the metal salt inside each star. It's chemistry in action, painting the sky with every explosion. Fireworks are, at their core, a celebration of the elements, each one showing off its true colors when excited by heat. It's a spectacular demonstration of science that we can all enjoy. It took centuries of trial and error, experimentation, and a bit of luck to discover which elements burn safely and produce the brightest, most beautiful colors. Early chemists and inventors risked a lot to bring us the fireworks we know today. Today's fireworks are the result of generations of curiosity, creativity, and a love for colorful explosions. Every display is a testament to human ingenuity and our desire to light up the night. Every fireworks show is a perfect blend of art and science, with chemists and artists working together to design unforgettable spectacles. So the next time you see a burst of color in the sky, remember, behind every explosion is a world of chemistry at work. Science truly is awesome, and it's all around us. Now let's take a closer look at some of the colorful elements that make fireworks so spectacular. Reds and yellows are some of the most striking firework colors. Deep red comes from strontium salts, like strontium carbonate, which release red light when heated. Bright yellow and gold are thanks to sodium compounds, such as sodium nitrate. Even a tiny bit of sodium can add a yellow tint to other colors. Chemists fine-tune these mixtures for the purest, most vivid colors. So, when you see a red heart or a golden willow in the sky, you're seeing strontium and sodium in action. Understanding the science behind these colors makes every fireworks show even more fascinating. Greens and blues are the cool stars of the show. Green fireworks use barium salts like barium nitrate to create a vivid emerald glow. Blue is the trickiest color, made with copper compounds but only at just the right temperature. If it's too hot, the blue fades, too cool, and it's barely visible. Achieving a deep blue is a true test of a chemist's skill. So, when you spot a brilliant blue firework, you're witnessing a chemical balancing act. Greens are easier, but blues are the mark of a master. Together, they complete the rainbow in the sky. What about purple? There's no single element for it. Chemists mix strontium, red, and copper, blue compounds to create purple. Balancing the temperatures so both colors shine is a real challenge. A perfect purple is a sign of true pyrotechnic artistry. For brilliant white or silver, metals like magnesium, aluminum, and titanium are used. These metals burn white hot, creating intense flashes and sparkling trails. Different metal flakes produce different spark effects: strobes, glitter, or long trails. These effects add texture and magic to the show. So, when you see a flash of white or a shower of silver, that's burning metal at work. Fireworks are chemistry's art in motion. Have you ever wondered how all those brilliant colors and shapes end up lighting up the night sky? The secret lies in the fascinating science and craftsmanship behind every firework. But how do all these chemicals and effects get into the sky in the first place? It all starts with building the firework shell, a process that combines tradition, precision, and a bit of artistry. Skilled technicians carefully assemble each shell by hand, ensuring every component is in the right place for a perfect display. The shell itself is made from a tough paper tube, designed to withstand the intense forces of launch and explosion. Inside, every layer is packed with precision, because even a small mistake can change the entire effect. At the very bottom sits the lifting charge, usually black powder. This is the explosive that propels the shell high into the air, launching it from a sturdy mortar tube with a powerful burst of energy. Above the lifting charge is a time delay fuse. This clever piece of engineering ensures the shell doesn't explode too soon or too late, but right at the perfect height for maximum visual impact. The top section of the shell holds the real magic, the bursting charge and the color-producing stars. These stars are small pellets made from chemicals that burn in brilliant colors, and they're arranged in specific patterns inside the shell. When the firework is launched, the fuse ignites and burns as the shell soars upward, timing everything perfectly so the explosion happens at just the right moment. At the peak of its flight, the time delay fuse ignites the bursting charge. This explosion is what sets off the stars, scattering them outward in a dazzling display of light and color. The way the stars are arranged inside the shell determines the pattern you see in the sky. If they're placed randomly, you get a classic round burst. But if they're arranged in a shape, you might see a heart, a ring, or even a smiley face. Creating these effects is a blend of chemistry, physics, and artistry. Chemists develop new compounds for brighter colors, while technicians experiment with new shapes and effects, always pushing the boundaries of what's possible. Every firework is a carefully timed, high-flying chemical reaction, choreographed to create a moment of wonder. The timing, the chemistry, and the design all have to work together perfectly. That's how the magic happens overhead, turning simple ingredients into breathtaking spectacles that fill us with awe and excitement. Next, let's take a closer look at what happens in the very moment of explosion, when chemistry and artistry combine to light up the night. When the time delay fuse reaches the bursting charge, the real show begins. The bursting charge explodes, creating a shockwave that ruptures the shell and throws the stars outward. The heat ignites each star, starting its own chemical reaction. Inside each star, fuel and oxidizer burn, heating the metal salts. The atoms get excited, then release energy as colored light, each element with its own signature color. Strontium glows red, barium green, copper blue. The sky fills with thousands of stars, each releasing billions of photons. The pattern and color are all determined by chemistry and careful design. It's quantum physics and artistry, lighting up the night. That's the science behind every burst. Firework chemistry is full of surprises. Crackling sounds come from compounds like bismuth oxide, which create mini explosions. The loudest booms use special powders designed for maximum sound. Fireworks date back over 1,000 years to ancient China, where they started as firecrackers to scare away spirits. Colorful displays came later, perfected by Italian chemists. Modern fireworks are cleaner, using nitrogen-rich fuels for less smoke and better environmental impact. Some stars change color mid-air, thanks to layered mixtures that burn in sequence. Every effect is a clever bit of chemistry in action. Why do we celebrate with fireworks? It's about joy, wonder, and coming together. Fireworks are a universal symbol, used in festivals from Diwali to New Year's Eve. They unite people in shared awe, breaking down barriers for a moment of collective wonder. The tradition began with scaring away evil spirits, but now it's about marking special moments. Fireworks are temporary, beautiful, and unforgettable, a tribute to moments we want to remember. They blend art and science, showing what human creativity can achieve. Every burst is a celebration of chemistry, physics, and ingenuity. Next time you watch a grand finale, think of the science and history behind it. Fireworks remind us that science can inspire and unite us. That's something worth celebrating.